In this example, we've got some questions that are a little bit more difficult, and we're going to go through approximately, I think we're going to do 4 of these, although it might be a little bit out of order. I don't know if we have a C. I think we have A, B, D, and E. Well, I hope this makes sense according to the notes that you might have found online. Alright, anyways, part A here, an arithmetic sequence has a formula of a sub n is equal to negative 8n plus 147. And we want to look at the position of the term that has a value of negative 181. So we don't know what n is. N is that position. Well, we know that a sub n has a value, or this term has a value of negative 181. So we're going to take that a sub n out, put in negative 181. We've got a negative 8n plus 147. Again, we're looking for n. To solve for n, we'll subtract 147 from each side. I'm going to switch sides on you now. I'm going to take that negative 8n, put it over here. I'm going to take this and put it over on the right side. So we've got negative 328 here. When you perform that arithmetic, we'll divide by negative 8. We could do this by hand, but it'd be a nice opportunity to use our calculator. So we'll do negative 328 divided by negative 8, and we get positive 41. What this means is that the 41st term will have a value in this sequence of negative 181. Let's work with part B. Part B says consider the following arithmetic sequence in which the values of certain terms are unknown. And our question is, what is the common difference of this sequence? And I think probably we're going to have to fill these in. At first glance, this seems kind of tough. You could do a lot of guess and check. That would work eventually. Let me show you a different way to approach this though. If we want to go from 3 to 33, and we're missing a few terms, we're going to have to add whatever D is once, twice, 3 times, 4 times, and actually 5 times to get from 3 to 33. Each one of these arrows represents that D. We don't know what it is. We know it's positive, though. If we're going from 3 to 33 and adding, we're going to have to be adding a positive value. The difference between 33 and 3 is 30. And remember, even though you see 4 blanks there, you're not going to be adding D just 4 times. If you look at the arrows, you can see quite clearly that we're going to have to add D 5 times. So we're going to take that 30 and divide it by 5, and that's going to get us 6. So let's think about what that means. If we add 6 each time, we should go from 3 to 33. Let's check it just to make sure. 3 plus 6 is 9. 9 plus 6 is 15. 15 plus 6 is 21. 21 plus 6 is 27. And 27 plus 6, that's the 5th one, is definitely 33. So these values fit in there quite nicely. You could have come up with this answer if you guessed. If you guessed maybe 4 and it was too low, and then guessed 5, it was too low, and jumped to 7, it was too high, and then back to 6 or something like that. You would have gotten it as well. However, this is maybe a little bit more elegant of a solution. Let's go backwards. If we go backwards, we'd have to subtract 6 each time, and 3 minus 6 is negative 3. So you can also find terms by going backwards if you'd like. Notice how every single time, if we go left to right, you're adding 6. That's the common difference. So the common difference, we could put D maybe is equal to 6, is just 6. Now, we've got D and E here, so let's see, I hope, we're kind of skipping C, I hope that wasn't a misprint. Anyway, we'll move on with what we got. And so we'll consider the following sequence: 150, 141, 132, 123. What is the value of the 31st term in this sequence? Well, what we could do is we could write all these terms out, and we could just count them off and say, well, this one's the first one, second, third, fourth, fifth, sixth, and so on. But I think that's going to take a while. I'd like to write a formula here, and I'm going to write a formula. A sub n is equal to the first term plus D times n minus 1. Let's see if we can figure out what D is for this one. Well, to go from 150 to 141, we'd have to subtract 9. If we subtracted 9 again, we'd get 132. Subtract 9 again, and we get 123. So I think D for this one is negative 9. Remember, even though you're subtracting 9, we want to think about what are we adding each time, and we're adding a negative 9. This is n minus 1. And if we write our formula here, We've got 150 minus 9n, I'm using the distributive property now, plus 9. And a sub n is equal to negative 9n plus 159. And we didn't really have to write a formula for this one, so I suppose you could just plug 31 in for n right away. That would be fine too. But we can do it right now, and if you ever have to list the formula for this one, sometimes it's called the general term, then now you know how to do that. So a sub 31 is going to be just negative 9 times 31 plus 159. Let me try that in the handy-dandy calculator here. So we've got negative 9 times 31 plus 159. That's negative 120. So in this sequence, the 31st term would be negative 120. In part E, we want to know the 88th term for the following sequence. 1, 2, 4, 6. Well, for this one, you would add 1 each time, or add 1 and then add 2, and so on. Let me change this on you a little bit. This might be a typo. Let's just start this one off, and I'll use the black marker here. Let's just start this one off as being 0 for the first term. I think that's going to be better for us. We actually wouldn't be able to figure out what the 88th term would be given those original numbers. There really isn't a pattern we can decipher. So let's see here. We would add 2 each time. So D is 2, and I'm going to skip this part of writing the general term or the formula here. I'm just going to go right to a sub 88. And that's 0, the first term, plus D, which is 2. We're adding 2 each time. And then it's going to be times 88 minus 1. So it's n minus 1. That's your position right here. 0 plus anything is just that same thing. So we've got 2 times 87. And 2 times 87 would be 160 plus 14, or 174. So in this sequence, if you went out to the 88th term, you would find that value sitting there would be 174.